So we're up to week 5. So today really what we'll do is I'm going to talk a little bit, as I usually do, get it out of the way early, and let you just draw and do some checking and that sort of stuff this afternoon. I'll come around and have a look at what everyone's doing and answer any questions, etc. So the main thing we want to sort of finish today is to make sure our site plan's got everything on it that it needs. So we check our site plan and make sure we've got, any additional details that we didn't have from our preliminary. We want to also add in our door and window schedule. So we didn't necessarily have to do that in the preliminary because we had the door sizes and the window sizes on the plan. So we probably need a bit more detail now in terms of the schedule to identify if there's any unique materials or sizes, etc. You don't necessarily always have to do a door schedule with your submission to council, but it's something that you'd need eventually for builders to start selecting doors and things for sizes. Is the one thing, but colours and paint finishes and all those sorts of things, because obviously in a house you've got internal and external doors. They're going to have different finishes usually, so that adds that detail to it for the contractors and for people to be able to tender. So you don't necessarily need that detail for council, as long as they know the sizes of the doors, how much they open, etc. But you always need the window schedule to be a bit more detailed, and any doors that have got glazing on them. So you may as well do your window and door schedule, and then you can add that on now anyway. Why you need to have all the glazing is obviously for your assessment in energy rating, if you're going to get it done like that, or if you're going to do your deem to satisfy and use a glazing calculator, then obviously you need to have that information on your schedule so someone can actually find out what you're using, and you can do it if you're doing your glazing calculator. We're not going to do the glazing calculator. We're going to assume that this is just done by an assessor at another stage, etc. So just show your window schedule and door schedule, and whatever columns you feel are appropriate for this. So I wouldn't worry about suggesting double glaze for this little one, because we haven't gone down that route at this stage. But usually that's where you would show which ones are which, etc. And it might be the case that some aren't double glazed if you're using double glazing, and some might just have some low E coating, those sorts of things. So there can be so many variants with doors and windows and that sort of thing. So that's why the schedule makes it a lot easier to populate that information. One thing I will say with your door and window schedule, if you've got fields in there, so like comments and all those sorts of things, and you're not using any of them, don't put it in there. Don't leave a blank column in your schedule, because it just means that if you've got a column that it says comments or something like that and it's blank, someone usually thinks that you've missed some information, because why would you have that if you haven't got anything in it? So just go in and edit the fields there and take that one out if you're not using it. We'll have a look at the details that we're going to do. So we're just going to do that one detail and section. So we'll have a look at those today, where to put your section if you haven't done it, and what we might put on the section and what might go on the detail. So one versus the other. And then you'll have time to sort of complete those details and sections, and then start to go through the checklist. Get your time management revisions done if you haven't done anything like that, because that's going to be updated next week when you submit anyway. And then I'll also just really briefly go through assessment 3, which is the next drawing project. So I'll just give you a heads up, and we'll start that next week. So we'll still concentrate on this, but at least you start to think about what you're going to go into. So you want to make sure everything from this one's finished and submitted. So next Wednesday we'll start with a fresh slate, and we'll go straight in and start drawing. Sound all right? Any questions so far? No? I will also show you how to put the roof sheeting on the roof and do a ridge capping as well, set up a ridge capping profile. So why we sort of start to sort of think about doing that when we come into this stage is because obviously the ridge and the roof sheeting is quite important when we start looking at the details. So when we look at say a section view, I'll go through this one. We want to be able to show that we've got that roof sheeting coming over into the gutter as well, and we've got the space there to put our purlins on. So it makes it a bit easier if you've done the ridge, etc. You don't have to add in lots of detail lines. It's just there in every view and every detail that you do. So this model is one of Russell's, and he set his roof up a little bit differently. So what he's actually done with his roof is he's set it up, if I just hide that, with the roof, the gap and the sheeting in one roof. So he's actually set some layers on there. But what happens when you do that is you can't extend the roof sheeting past the edge of the rafters, so you don't get that overhang. And so why I've just hidden that is what you can see is what he's had to do is actually detail line in the sheeting hanging over. So if I just get that back, you see it looks pretty good there. But that's what that is to get that over the edge, just those detail lines, because it actually sits in there. So I tend to do, so that's a good way to do it, like there's no problem with doing it that way. But what I tend to do is actually do a separate roof over the top that I actually make the 16 mil, so the thickness of the top to the bottom of that profile. And then I can just offset it from the existing roof. Okay, so what do you think might be a good way to do that secondary roof? Any guesses? Because we've already got one roof there that's in the right place. Yeah, so I just do a copy of that roof and do a paste in the same place, but then give it an offset. And then I go in and duplicate that roof. So I do an edit properties or go into type properties, duplicate it and change that one to 16 mil. So then it just sits above perfectly, so I don't have to worry. And then all I've got to do is edit the sketch and extend the outer sketch lines just far enough so it sits over the gutter. All right. So it's a pretty quick way to do it. And then the offset distance in there is the distance between that roof and the thicknesses of those battens or purlins. So they're 90 by 45. So 45 distance between there. So you should be able to manage to do that yourself and just set up. I can help you later on if you want, if you're having trouble, but you should be able to do that. So I'll let you have a go at that. But to do the ridge capping, it's probably something you haven't looked at before. The roof capping is usually just a sweep. So I'll go back to the 3D view. How you can set that up is actually just drawing that profile. Russell's actually drawn like the exact profile. I wouldn't go to that much detail because you don't actually see it in that much detail anyway. What you need to do is just sort of get an idea that it's got a little bit of a curve on the top. It's got some straight edges and it lips down a little bit. So if we look back at the section and have a bit of an idea of what's happening in there, that curve is about 25 high in there, and the whole length of that capping, or the width of that capping, is about 250, 260 would be fine, okay, for what the purpose that we're going to show. So what I would tend to do is, in my 3D view, I set up a profile, and I use the roof, sorry, roof, not floor, not that one, fascia tool. So you know how when we did the fascia on here and then we did the barge board, we used the same tool but we changed the two profiles? Exactly the same thing. I make a third profile, duplicate one of those fascias and call it ridge capping, and that one's got that third profile loaded in that I've sketched that shape that I just told you. It's about 250 long. It's got that little curve on the top, and actually then you can just touch the top line of your roof and it'll just sweep across that top line, okay? Because that essentially is how that fascia tool works. It's a sweep going on the edge of a roof profile, okay? So if you've got like a hip and valley sort of roof as well, so obviously you have sort of the ridge capping being a bit bigger like we're doing now, but then you've got just a smaller profile capping as well. So you can draw that as well and put it as a different capping. And that just gives it, you know, the effect that it's got that capping rather than, you know, these normal roofs just have that straight line on them. So does anyone remember how we set up a profile? Has anyone done it before? I can never remember it. So up in the file button, you just go into new, and then we'll go into a new family, and the type of family that we're going to set up is a metric profile. So see how there's all these profile templates. So if we go metric profile open, that pops us out into the sort of family editor, but it's blank canvas. So we want to just draw our profile in here. So you just go into the line tool, and this is where you just start sort of sketching approximately what you want. So I'm going to sort of just do something like that to start with, and just sort of get an idea of what that measurement might be. So it needs to be a little bit longer than that. So if I make it, say about 75-ish. So the Create tab on the top gets you back to your lines, and obviously all your line types are there. I'm just going to draw a circle on the top there. And I'm going to do a mirror of this one. And then I'm going to trim that around like that. So you end up with something like that. They can be, yeah, yeah. And so you can go into like the Fielder's website if you want to get like perfect and actually see what that, you know, measurement is exactly. So I think I measured from there to there was about 25 or something like that. So mine might need to be a little bit bigger in there. in that circle. And you probably want to follow it too, because they usually bend it to the pitch of the roof. So we're at 15 degree or something like that. So probably I want to draw that a bit better than that. Like you're right, Leanne. Good pick up. Actually change it. So my mouse isn't working very well today. Yeah. Did you steal mine last week? So once you finish your sketch, what we need to do is actually do a save and save this profile with a name that we want. And so you save it into your files that where you're saving all your thing or your other additional families and things like that. So save as a family, and then you save it into wherever you want it, and we'll call it ridge capping or something like that. So give it a name that you're going to be able to identify. Now I'm just trying to think, I've got a 50% chance of getting this right now. I've got a memory blank and I don't know whether I need to actually offset this and give it a thickness. I think I do need to give it a thickness and then load it in. But what I'll do first, before I give it a thickness, I'll try to load it in just as a single profile, and I'll get an error to say it won't work if it was, and I can go back and change the sketch rather than change it. But I'm pretty sure I need to give it the thickness of the metal and make it like a closed loop sketch. So I won't close it, I've saved it, but I'm just going to load it into the project now. So it's called, as long as you've got a name up there, ridge capping, otherwise it'll just go into as family 1 or something like that, and you'll be searching for it. So I've done a save as, which is now still in the window as ridge capping up here. Now I can go load into project. I'm not going to close and load into project because I probably want to come back to it, keep it open to change the sketch. So load it into this project that was open. I'm going to come to my roof fascia tool, and I'm going to go into the properties of that one, and I'm going to edit that one, duplicate it, and call it ridge cap. And then I'm going to look for that profile in here. So we got ridge capping. Say OK. And I was right. So I should have backed myself, but it was a Wednesday morning. So I need to make the thickness of that capping for it to work. So see, it says could not create fascia. So I'm going to open it back up here. I'm going to grab all of that, just do a quick copy, grab it from that corner down to there. I'm just going to give it a few mil thickness. I've got to put a couple more closed loops on it. There and there. I'm going to save it again. So it's still just saved over the same one. Load that one in the project. It'll ask me to override the existing one that I'd already loaded in. And then I can come back into my roof fascia tool and ridge cap. Oh, hang on, it's that same one. And for some reason mine's not working today. Anyone else get theirs to work? Should work for you. So that's Russell's profile for his ridge capping. You can see it's the same sort of thing, but he's just put he's followed exactly. So how Russell made his was he snipped a picture from the fielder's, like one of the diagrams from the fielder's catalogue, and he imported that JPEG into his Revit, and then he actually could trace over and get those angles and divots, etc. completely right. And because we've just used the roof, our roof was 125, did we use to start with, or did most people, their actual roof was a generic 125, or did you start with something different? 125. So what I would do with that roof is edit that roof and make it just 90. So we want to replicate what the truss top chord is, the thickness of the top chord. And a top chord is usually, probably for this project, it would only be 70, be a 70 by 35. But if you allow 90, it's fine. Okay, so sometimes they do use 90 on bigger jobs. This is a small job, so I would imagine they'd be using a 70 by 35 top and bottom chord, plus the webbing members. Now I was going to also mention in the section here, you can see that Russell's gone to a lot of effort to actually draw the thickness of his trusses, like cords in the trusses, so he's shown that. But what this detail line is showing another alternative. You can just sketch your lines in there and you don't even have to have your nail plates on, okay? Because the truss isn't being designed by us, it's being designed by a truss manufacturer that also produce the truss drawings and yeah, sheet sets, basically, layout settings and all that. So you don't have to replicate it on your drawing as long as your drawing identifies that it's a truss by the manufacturer's details, which those details are going to be part of our drawing set because they're going to come with it. So if we look at the river gum example, oops, just to sort of show you what they've done, there's their section in the middle there, and so that's really all the detail that we would need to show, which is what we're doing. We're showing that there's a ridge, that we've got a roof sheeting, that we've got the right size purlins. This is replicating that it's a truss. Everyone knows it's a truss if they see that, and a bottom chord. Okay, so the bottom chord can just be a detail line offset from our top of our ceiling. So when we put the ceiling in, detail line, that one's a detail line offset at 70. You can do a 90 if you wanted. If you're using 90 thickness, we've changed this roof to a 90 thick, and then we're going to have that roof sheeting offset at the 45 distance. So you end up with those layers, and then, as I said, that top roof sheeting that we've made 16 mil, we just edit the boundaries on the outside so that they come out to the gutter, so they just overshoot the gutter. If we look back at Russell's, and the other alternative for this roof is to set it up like this. So he's set up that roof being the structural element, the 90 thickness of the truss cord, thermal air barrier, 45 being the purlin spacing, and then put the metal decking on the top, custom or at the 16 mil. But the core boundaries around the top and the bottom, because the whole thing's a structural element working together. So
if you set it up on there like you do with the web cord, where you can pull that down separately, could you do that way?
To pull the end out?
To be on the outside of the core boundary, is that right?
No, it doesn't allow you to pull things out here. You don't get little arrows with a roof.
Okay.
Yeah. So yeah, good thinking. Yeah, the walls. Yeah. So yeah, it doesn't give us those arrows to actually stretch out.
So it's not with any. You say you can't just use that with any element.
No. So that's why I always usually do it, set two separate ones, because then you've almost got what the products would be, two separate entities. One goes on first, the next one goes on, and then just in your detail in your section, you're going to create those detail elements, which I think you've already got loaded into this template, which are some studs for your bottom and top plate, noggins, and you can just use one of those and tilt it on the 15-degree pitch. You get into your section. Now, when you come,
you were doing your tables on your drawings, you would want to do it that way anyway.
Yeah, because then you've got the different product. Yeah. That's sort of why I tend to go in like that. So with these detail elements here, these timber sections, so like I mentioned, you should have those in your drawing. So that's the noggins, top and bottom plate that you'll show. Those, when you actually grab one of those, when you go to place it up here, just hover the center point over the one of the roof lines and hit your space bar, and it'll actually rotate to the 15 degree. Some people might know that. I often get people in this class that spend, 15, 20 minutes trying to rotate it properly and that sort of thing using the rotate tool. So as long as you've got that hovering over it, when it picks that line, it'll actually use that as the reference. If you're just floating out here, it doesn't have any reference, so it'll just go horizontal or vertical. So they're going to be at 1200 centres because it's a sheet roof. So start quite close here, do pop your first one in, and then do an array at 1200. So your second placement for your array is going to be 1200 from the centre of that one to centre of that one. And I usually would just do 4 to start with. 1, 2, 3, 4. Yep. So 5 works in that case. You probably find that spacing might have had to be reduced to fit the 5 in evenly. And then once you've got one side done, just select those and mirror them on the other side. Okay. And as I said, you don't have to put the nail plates and those sorts of things in. Russell just stays awake too long at night doing this sort of stuff. He's even got like the the clip on the end. You don't need to show that. This detail is going to be about this big anyway. So it just looks like a line. Soffit lining, you will have to put that in to show your detail. So just do your normal soffit lining. But when you place that, you'll just need to nudge it up so it fits into that little notch of your steel or metal fascias. You should have a little notch. That gives you the height. And it just goes back into the stud, and the cladding starts just below it. There's a little quad mould there. And that's just another one of these just turned around and edited to 70 mil. And that just supports this. This is a detail line here, which is the soffit bearer. So the soffit bearer is attached to the stud using that little trimmer there. And it just comes out and is attached to the end of the truss, and that helps support the truss, gives it the overhang allowance, and obviously gives the soffit something to attach to on this end as well.
So when replacing the soffit, you use that to place it? Because I haven't done soffit.
Oh, so I can do that quickly for you too, the soffit lining. And we did yours yesterday, Pauline. For some reason I woke up at 3 o'clock this morning and went, oh, we forgot to do your gable ends with the soffits. We only did the straight one. So we'll do those, both of those. I'll show you how to do both of those now. See, I think about my students at 3 in the morning. I often get crazy Revit things pop into my head and wake me up. It's really weird. So you work on your ceiling plan for that. We'll do the soffit, so everyone's got that on the recording.
Jason, how thick did you say today the main part of the roof? Was it 90 mils? Is that what you said?
Yeah, you can do 90, 70 or 90 would be fine. Yeah.
It's a shortcut for
OF.
Can't be.
Is it?
Just do anything.
So this is a ceiling level view. So I'm just going to go into the architecture tab and go to the roof drop down button and hit the soffit lining. Now, have you got a soffit lining loaded in that's 4.5 mil? Something like that, Hardy Flex one. So you don't even have to look that up. So that's good. That's part of the template. So use that one. There is an offset in minus 94, which is probably going to be where you'll do it. But if you start with 0, that'll be fine. I'm just going to start with 0. This is generally how I would do it. Just ignore where it's going to sit at this stage. You're just going to put it at the ceiling, go into the section, then we can nudge it up and down into the right place. So what we need to do is, because we've got gable ends, they're obviously sloping up. So we'll ignore them for now. We're just going to do the two straight sides that are flat. So that's going to be from this edge here, and as I said, it'll go to the stud layer, and it'll go out to the outer edge of where your roof sketch is. So you should be able to see your roof outline there. And I think to fit into the notch, it actually comes in from that by about 7 mil, the top of my head. Do you remember what we did yesterday, Pauline? Was it 7 mil?
I think I nudged it a little bit up.
Yeah. So we can just, well, I'll just do one quickly to show you, and you basically sketch the other side. You can do it in the same sketch, but I'm just going to use the pick line and come down and pick this inside. So that's the stud there, and then I'll pick this roof to start with, and then I'm just going to sketch 2 lines to straighten up the ends. So that's where it will finish, and another one here. So just at the end of the house, don't extend it to the overhang on the gables. And so you could, in the same sketch, you could do this side as well. And once you've done that, you just tick it. And if you go then to the one of your section views that's looking across, there's mine sitting up here at ceiling height. Okay, there's the soffit line in there. So by nudging it down, we can get it to come down and sit in that little notched metal fascia. And so you can see by using the outer, actually I'll just I'll hide Russell's for a minute. So there it is there, but it's too long. So the distance from the end of it to there, I reckon, was 7.5 mil will make it quite nice. So when you come back in, let's go back up to the ceiling level and edit the boundary of that one. So from that outside edge, which is the roof edge, I'm going to move that one 7.5 mil. There it is there. So once you've done this side and you've got that right, what I would tend to do is select that one and do a mirror, and we'll mirror over the ridge. I can't see there, so I'll use that one, and then I'll just place that one out here. So that one's going to do both sides at once. So you can see I'm just nudging that into the right spot. It'll sit there, and then tick it to finish it. And in your 3 section view now, I've got one sitting at the right distance. The other one's going to be over here. There it is in there. All done. Okay, so that's the 2 flat pieces. So that's just the soffit lining. To do the gable ends, obviously what we've got to do is the same sort of thing, but we need to give it the pitch so it sits up in under here. If you're not putting a section through these ends, so there's Russell's there, I wouldn't bother about doing it because we're not going to see it in any view. So if you do it, it's just so that you've done it. Right. And that's where I suppose you've got to start thinking, especially for the next drawing, how much of this model am I actually modelling to get it to council and get it built? Because sometimes you have to ask yourself that question, because you might think, I've just done 2 hours of modelling stuff and no one except me is ever going to see it. So unless someone's going to use the soffit in Revit to take off how much soffit lining there is, and you're not seeing it in any of your views, then it's a waste of your time. So if you were doing a second section through both ends, yes, you need to do it. It's quicker to do that than try to add detail lines in all the ends, and it just gets messy. But for this exercise, you probably don't need to do it. But I'll show you how to do it so you know in the future if you haven't done one of those before. So it's exactly the same profile. So I would start at the ceiling level again, and really you're just drawing in the same thing. So we'll go roof, soffit, and we're sketching the line. So it was a 300 overhang from the edge. So to there. Again, just a single line to finish where it hangs to, which will be along there. And what we need to do in the middle is actually finish it at halfway, because remember it's coming up 1/2 and 1/2, 2 angles. So we sketch another little line in the centre of the building. And I know that's not the exact centre, I think the centre's that ridge there, so let's just align that one to, oops. And so once we've done that, so if we finished that one, it would be sitting in the 3D view, just flat. Okay, so we need to give it the 15-degree pitch. So we can go back in here and edit the boundary. And what we need to do to give it a slope is to add a slope arrow. See that tool? You've probably never noticed that before. It's in a few of the tools, but if you add a slope arrow, you can see the diagram showing you what's happening there. Within the sketch, it basically draws a little arrow, and then you can actually either give it a pitch or give it a distance from the tail to the head of the arrow. So we'll do that. So hit the slope arrow. So it's just sketch lines. You can either pick line or draw lines. And what we're going to do is start it here and go up this way. And then by picking the arrow, you can see the arrow here, you can specify height at tail or slope. You've got 2 options. So if you use the height at tail, you've got to work out how high the bottom of the arrow is going to be, and then how high the top of it. So you might use that sometime. That used to be the only way to do this till about 3 years ago when they updated Revit. They finally put a sloping, because it used to be a nightmare trying to get the distance. You have to measure it. So now you can actually just specify the slope, and then that allows us to add in the 15 degrees. Now, I'll probably put my arrow at the wrong. Did I put it the wrong way? Let's have a look. And then I can see now I've done it right. So it's actually there now, and now it's just how far it's offset. So I can go into maybe this view here, and then nudge it down till it gets to the right spot, or put a section through that way and do it. Okay. And so again, once you've done one, don't mirror the sketch lines, mirror the finished result. Because if you mirror the sketch lines, it's going to have the tail going, like then you've got to put your other tail in. So like I did with the other fascia, I just sketched it, mirrored it, that's fine, that's all we want. But with this one, finish it. Once you've got it there, just mirror it and it'll be fine. The tail and everything's just part of it then. But as I said, you don't need to do it for this project, because we'll never see that detail in any view. Okay, so that sort of takes care of the roof, and then when you start to do your detail, and remember the detail for this project, we're just going to do that one. So our section, we're going to do it 1:50. This is the only real detail we need to show. You could probably put a bit of insulation in the top as well, and maybe a little bit, few notes around termite protection down here. But you don't need to show any more detail than what they've showed there. Inside your section you might see some internal walls, that's totally fine. If you do, just put a top and bottom plate on the walls and a noggin at the right spot. There's Russell's with a lot more detail, but so just a few notes like insulation, sheeting is specified, or you might actually put that it's 22mm structure floor, and just put your room names that you're seeing. You've got a cornice, I think, loaded into the project. You can put that on and put the skirting in here, but I wouldn't put it in the section because it just ends up being little dots anyway. Just save that for the detail when it's a bit bigger. So the only detail that we're going to do is this one here. So you can do it as 2 like this, which is coming from, it's just about to zoom over to. It's basically coming from this side here. So this is the detail that we're going to do, which, as I said, once we've done the roof properly, we've got everything here that's modelled. We don't have to add any detail lines. All we're going to add in is obviously these detail elements being the purlins, some insulation, which is just that insulation tool, insulation in the wall, and then your top plate, bottom plate, and noggin. And then the next thing we need to do is just load this group in, which we've already got all the floor. Okay, so I'll show you how to load the group in. And then you can set up the ground level and have a bit of ground and a bit of compacted fill like that if you want. Okay, and that's just with a region. I'll show you how to do that as well. And then it's just a matter of putting your notes on. Okay, so not many notes on the actual section. Keep most of them where the detail is. Okay, so probably it's important to have what the overhang is as a dimension there, so you can put that dimension up here if you don't want it shooting through these lines. But when you do your notes for the detail, what I like to see is anything written on the right hand side justified to the left, so you can see that all of that text is justified and starts at the left hand side, so then the arrow shoots over. And anything on the left side justified at the right. They haven't got that done here very well. They've done it for this one, this one, this one, and this one, and this one, but they've actually missed 2 or 3 of them are justified left, so it's a bit uneven. So it's just a matter of going through drawing and saying, right, now I just want to re-justify those so that they all sit in closest to the arrow. That makes sense? So you can see on this detail they've actually done it nicely. But this one it's just a bit messier. So let's load in the group, and that's the just while I've got this section open, that's the 2 regions that Russell's done in his that show the compacted fill and the ground. So they're just regions, filled regions. So annotate region, filled region, and once you get the filled region up, you come over here and you just edit one of them and actually change the patching pattern in there and just sketch it in. Now how Russell's got his done is that he's actually, with this one here, his boundary lines are just thin lines and they just go out further than where he's cropped his view. so you don't see that sort of square block. That makes sense. So once it's finished, you can see where he's cropped the view to there. So if he had cropped his view down here and out there, it sort of looks a bit blocky. So by cropping that in and just taking that edge off there, it sort of just disappears, which looks, I think, a little bit neater. All right. So if you open up Learn in the project 1 area, you should see under the floor framing heading, a floor framing group version 2. I've put a few notes in there. So the origin point, I'll show you where it is, but it's the top right hand corner of the inside edge of the studs. I'll show you where that is when I load it into mine. Once you place it there, what you need to do is change the level to ground level, because it'll come in we'll put it in at our finished floor level, just so that we can see our studs, and then we'll just change it down to ground level. So when it comes in at finished floor level, if you don't change it to ground level, it actually looks wrong, because some of it starts to stay up, so there's gaps between the joists and the bearers, so you must change it. Once you've changed it, if you've mirrored your project at all, it'll be totally fine. You'll just be able to mirror it once it's at ground level. Who's mirrored their project? Just you. So you can just bring yours in anywhere and we'll just mirror it, and then we can align it to the right spot. That'll be the easiest. Don't worry about the insertion point. Yeah. Oh, actually we could, insert it at the bottom of the opposite side, and then we can mirror it over that axis, and it'll be perfectly in place. That'll be probably easy. So, so what we need to do first is save that group somewhere. So click on that group and save the file, and save it in your project files where you've got your families, etc. Have you done this before, Sheena? Everyone got it somewhere? Know where you can locate it? So now that we know where we can access it from, we've got to do two things. We've got to insert the group into the project, and then we've got to place the group from the project. Do you remember doing this when you did Revit Intermediate? Yeah. So to insert the group, we've got to go to the Insert tab, okay, and go right over to where you usually load families. There's a Load as Group, and that'll look for, obviously, that group somewhere. So find where you saved it. And open it up. It'll probably do an upgrade. You might get a warning that says that there's already a level 8 millimeter head or something. Just say okay, that's fine. And make sure you're in your floor level view, in your finished floor level. And our insertion point is actually this up in this top right hand corner, and we're going to place it on the inside corner of this stud here. So if yours is down in there, yeah, down the bottom one. Yeah, same place, yeah. Because then we'll just mirror it on that we'll mirror it on that axis. So does anyone remember how we then place the group? So architecture tab, Debbie remembers, don't you? There's a model panel, architecture tab, right in the middle there's a model panel, and there's a model group button, which is a split button. So your button's probably bigger than mine hides there. And the top option of that button is place model group. So we're going to place the group. It has to be in the project before we can place it. So that's why we inserted it, just like sort of loading a family really. And go place model group. And in your properties, just make sure that it is the model group that we want, because sometimes if you've got other groups in your project, it might pick one other one. So mine says the floor framing group version 2, which is fine. And then basically just hover over where I said, so it's going to be looking for that corner. And what you'll find is when you hover over that corner, zoom in close until you see group origin come up. So keep hovering and zoom in a bit. You'll get a couple of things like a little cross that says nearest when you're pretty close. You might get a little corner one that says end point. But once you get right on that corner, the group origin should come up. Is everyone getting that up? You won't get it up, Pauline. You just place it on the corner.
It's just saying end point.
Yeah, just zoom in a bit closer.
Constraints not satisfied, so I just say remove constraints.
Hang on a second. Get everyone else there first. Everyone got it happening? Zoom in really close.
I don't get it if I zoom right out.
Oh, zoom out a bit. So you should have like a little circle emblem underneath your circle with a cross through it. Yeah, so if you've got that circle element, click. Have a look down at your prompts in the bottom left-hand corner. It might actually be saying origin down there. Does it say it down there? Yeah. So if you have it down on the bottom left-hand side, it's right. So then if you get a constraints are not satisfied, that's absolutely fine. Say remove constraints. And what we want to do now is click on the group that's placed. So you should be able to see it then. Click on it, and we want to change the reference level to the ground level. You won't get that warning. Mine's telling me that I've got identical instances already in the project. Okay. Did you get some other warning or? Yeah, that's okay because you've just got a generic floor and this is another floor overlapping it, so that's fine. Just say okay, yeah. And you should have a nice floor in the bottom now. So to pull the cladding down on the outside and protect this, we can actually pull it all the way down close to the ground if we want, because it's actually not timber, it's a compressed sheeting, so it's got cement fibre in there. So that's totally fine. And what would happen really is there would be a subframe set up that would actually be suspended from this bearer and joist and actually come down the inside here to actually stick the cladding on. along the edge, because obviously it just can't float. We don't need to show that detail. We're just going to show that it's, you know, it's pulled down on the outside. So if you ever went to buy like a transportable home from someone, Rivergum or who else does them? Sarah Homes, those sorts of places. So it might be you're going to buy one to a beach shack down at, I don't know, Port Elliot or something like that, and the base price might be $80,000 for that particular one. It won't come with the stairs, and it won't come with the cladding down the side. So it just finishes. But obviously you've got to put stairs in and protect it. You can pay them to do it, or you can say, look, I'm going to do that once it's on site. So that's why we're going to sort of tidy it up a bit and show what it would look like in the end. So if you go into maybe a section view and just click on one of your walls, go to edit type, and what we want to do with the timber stud wall that's got the cladding, so it's timber stud, so hopefully you've clicked on an external wall, yeah. And we've got to edit the structure, and what we're going to do is go in and get a preview of what that looks like. And in the preview we need to change the view to section, so we can actually see that wall standing up like it's in our section view. So once you've got that done, what we need to do is hit the modify vertical structure button. So there's a vertical structure modification panel, and we've got to hit the modify button. So when we hit the modify button, what that allows us to do through here, zoom in at the very bottom of it, and on the side that's your cladding, hit the bottom line and you'll see a padlock that's locked. So you've got to click on that padlock so that you can see it opened. So make sure your padlock's open. Only on that piece though, don't do it for the thicker 90 stud piece. If you unlock both padlocks, it sort of defeats the purpose, because then they move at the same spot. So you just unlock the one that we want to drag down past our base for where the wall is. So you might have to zoom in and out to get that padlock to unlock properly, but if everyone's working. It's a bit fiddly, sometimes the padlock button in Revit 19 or 2019 I've found. So once we've got that unlocked, just say OK and OK, and then what you'll find is that you will have two little grips when you select your wall now, not one, back in your section view. And one of those little grips, we just want to move it down to wherever you want to finish your cladding. So as long as it's down past the floor framing, yep, good. And so wherever you're happy with that to be, yep, that'll probably be good. Just do it to that one wall, and then to make life easier for yourself, go into your default 3D view and find the wall that you did it to, and click on that wall that you've done it, that you've got that. You should be able to see those two grips at different levels now by selecting on it. Go up to your match properties button. So up in the copy panel, once you've selected it, you'll see there's a little, I always think it looks like a calculator with a paintbrush. Click that button and then click the wall that already has the section dragged down, so the one that we selected. Click on that again, and what you'll see is the little paintbrush that's next to your icon will turn black. So if you can't select the face of your wall, it means your select button's not turned on down here. So make sure your select button's turned on down here. And once you've got that black paintbrush, it's grabbed the information from that wall, meaning it knows the information of how far that cladding's down. So all you've got to do is orbit around your model and click the rest of the faces of those other walls, and all the cladding will come down evenly. So you don't have to go into lots of section views and drag them down to the same distance. Okay.
Sorry, how far can we drag the cladding down?
Totally up to you, as long as it's past the timber framing members, but you can bring it right down to close to the ground if you want. Yeah. So if you're in a bushfire prone area, you'd have to bring it down to the ground because you can't allow embers to get underneath that house. If you're not in a bushfire prone area, you've got the option, just bring it down to past the timber members. And the reason you want to do that is any moisture rain is going to drip down, not get pushed into the side of the timber joists, which is going to suck the moisture in and swell and then damage to your framing. Ideally, you want it to the ground anyway, because if you're in our sort of climates, you wouldn't want that ventilation coming underneath as well, because that's going to make that house a bit colder in the winter. However, if you're in Darwin, you'll find they leave that ventilation under their house. They want that nice airflow coming through and cooling the house down, okay? But they'll still have it down over the timber cladding, because when they get their rainy seasons, they don't want that moisture getting wicked into the end grain of the joists and the bearers, all right? Just so you know where to look. If you look through on your assessment instructions, like obviously all the detail that you're going to do, but if you sort of start to think about what you're submitting for this last submission, there it all is there in this section. So this is what it says in the assessment, that it's the full set, but I'm looking for the cover sheet, site plan, full floor plan with all full dimensions, elevation fully annotated, sections, one section, that one wall detail, and our schedules, and remembering all the NCC details that are on there, which are listed down in this side here, and then just a screenshot of your folder structure where you've saved everything, and then obviously that time management calendar updated. Okay. So, I mean, where everyone was at last week with their preliminaries was excellent. You just got to add to that, just finish your dimensions and what we've done today, your details, etc. So, yeah, next week we'll be starting drawing project 2, which is assessment 3. So this is like probably the major assessment task, because it's the biggest one. It's going to be a townhouse that's set in Modbury, so Tea Tree Gully Council, and it's one of 6 townhouses. It was a project that I worked on about 9 or 10 years ago. It actually exists. So we've got all the engineers' drawings, all the trust drawings, all those sorts of things are going to come with this project as well, so you can start to see how that would work. There is also going to be a few more letters and interaction with clients and engineers and things like that. So the client's going to ask you for some changes midway through, and you've got to ask the engineer how that impacts the drawing that you've already submitted as a preliminary. They're not major changes. It's not going to put too much of a kink in your workflow, but it just sort of gives you a bit of an idea of what happens in the real world. Um, so it's a 2-story townhouse. We're only going to do one of 6. Um, it's going to be Hebel power panel, and it's got a relatively flat roof hidden under a parapet, and so that is going to require some box gutters as well. So we'll have to draw up some box gutters. So it'll change the way you're sort of thinking about your drawings a little bit, because it's slightly different from what you've done in the past. Apart from the letters to council, letters to engineer, letters to client, it's really the same sort of process as what you've been doing. It'll be research next week mostly, get your template ready, start some preliminary drawing the week after. We'll submit some preliminary site plan, plan elevation, and then I'll give you some feedback on that, and then you'll sort of go through, and that's when you'll make a few changes, etc., and get to the full drawing stage. We've got a few more weeks to do this project, so you know, you've got a few more weeks than you had on this one because it is a bit bigger. And there'll be, so probably, so I'll do it the same. I usually run it the same way as where I do the talking in the morning, and then show you a few things that you might need at that stage, and then you can use those things that day, and I'll help you in the afternoon and that sort of thing. So, because it's 2-story, it's going to have stairs. It's got balustrades on the balconies as well. So there's a lot more compliance issues. It's got 3 bathrooms, so there's some wet area details that we have to sort of work out how that's going to work. There's some double garages, and set down in the garage slab, so we've got that sort of thing to work out as well. We're going to do a few more drawings. We're going to get some more details out of this because it's more complex. So we, you know, apart from just that one long section, we'll do a cross section as well. So we'll have 2 sections with this drawing, and from that we'll probably end up with about 5 or 6 details to work through as well. And so this is usually, that's why it takes a little bit longer to do this one, because understanding how the materials work in the balcony set down and tiled and all those sorts of things. When you start working your details out, there's a lot of manufacturer's information you need to look at. And I've got a lot of those links on the site, so you don't have to sort of go off on a wild goose chase, but at least you can get the idea of looking at those. How am I going to interpret that and fit that in my drawing, and make it work? So yeah, so I mean, well, if you finish this one, but during the week, if you sort of try to start to look at this project, just to get your heads around what it might be, and I'll help you set the wall type and all that sort of stuff up, so it's not too Revit heavy. We'll get most of that stuff done next week when we start, and then it'll just be a matter of starting to sort of think, right, how do I draw this up? Has anyone worked with or understand Hebel power panels before?
I had a go at it in planning approval because I've never used people before, so Merrin sort of showed me a little bit how to draw on Revit, but
Yeah, so I mean, in terms of drawing the building, it's just a matter of putting the panel on the stud with a, you know, top hat, so it's not that hard to set that wall up. But in a planning stage with Hebel, power panel comes in a 600 wide panel, and so you can put them on the side or you can put them vertically depending on how you distribute your top hats. But one of the most important things to understand is Hebel shouldn't be cut smaller than 300 wide. So when you start to set out your drawing, that's one of the first things that you should start to think about. So obviously got a width and a length of a building, but how the panel is going to be butt jointed at the end, you know, is going to shuffle the panels down by the thickness of the panel and the cavity either way. So sometimes it's a matter of working out which side it's going to start on, which corner it's going to start on and go around, and also moving windows and doors slightly so that you reduce that 300 cut, because at some stage, you know, there might be a panel that finishes and as you've got 200 to a window, and what's going to happen next to that. So so you've got to sort of work all that out. So to try to minimise your small widths. And then there is often panels, like, so there might be some windows, small skinny windows near front doors, side lights and those sorts of things that just have, part of the design just has small gaps that need to be filled. Above garage doors and things like that, it might be a smaller gap. And that's where you need to decide what can I do instead of in there. So if we try to cut the panel too small, it just becomes really brittle and breaks. So what you'll notice if you start looking around at Hebel buildings is you'll see just some compressed sheeting, so like blue board and that sort of thing, and that's what you'll put in those areas. So they'll put some extra insulation in the back, but the difference in thickness of material between something like a compressed sheet and a Hebel panel is quite a lot. So then you've got to work out, how am I going to pack that up? What am I going to do? How's it going to be coated and all those sorts of things? So we'll have those sort of things to work around as well. So it's possible. It's just that one of the big benefits of using Hebel is it's very good acoustics, and it's quite good as an insulator as well. So it adds your R value to the wall quite a lot, considerably. So if you start putting, blue board, those sorts of sheetings throughout everywhere, you've really sort of defeated the purpose of using that product. So you've got to try to really minimise that. So sometimes with a job like this, it can take almost a day. Not that I'm going to expect you to take that long, because it's been worked out, but to actually figure out how that panel is going to work and try to reduce the shortcuts. If you ever go past any sort of houses being built with Hebel, what you'll notice is there's always loads of broken bits out the front of the build, because it is very brittle on the end. So Hebel's like all aerated, so it's the actual product doesn't have much strength in its own entity, but it's actually got mesh inside it. So it's got that grid-shaped mesh inside it, which gives it the strength. But once you get down below that 300, the grid's not really working very well, so the corners break and that sort of thing. So the last thing you want to do is, have a skip bin out the front full of broken panels, which you do see unfortunately a lot on site. This project, when we did it, was the star rating was you only needed 5 stars at that time to get through as a minimum requirement. When we used the Hebel panel, all of the townhouses, even though some of them weren't orientated the best, because of the situation in terms of where they were, how many the client wanted to squeeze on the site, they all got over 6 stars, and it was really down to the Hebel panel. Helped a lot with that. And we used the Hebel for that reason, but also because it was very close to the O-Bahn, and so there was some traffic noise right there, so we wanted, obviously that acoustic values as well. When we first did this project, this is just a bit of background information so you know about it, the client that came to us had, my business at the time, my business partner had a connection with my business partner through some work. She was an accountant at a workplace that he'd worked at before. She'd already sacked 2 architects that hadn't got it through council. It'd been going for about 5 years. So the pressure was on. Yeah. And we didn't get it through council our first attempt either. So we actually, the clients really liked what we did. We did something quite different to what they had originally. It got rejected for council because at the time they only wanted 5 townhouses on that size block, not 6. The client needed 6 to make it, well, they didn't really need 6, but they wanted 6 to make the money that they wanted to make, I suppose. It was like a family trust. So, however, so what happened was the council planning department really liked what we'd done, and they supported the application, but when it went to the development assessment panel, at the time there was a 15-person panel, and they all had to vote unanimously, and there was one person that didn't want it, and that's why it got rejected. But about 6 months after that, and we'd worked on the project for probably 2 years. It was a really long-winded project. So after that, 6 months later, we actually got a phone call from Tea Tree Gully Council planners that said, just to let you know, if the client still wanted to go ahead with that project and you submitted it as is again now, you'd get it through, because they changed the development assessment panel. One of the persons from the panel, apparently the one that didn't want it all the time, wasn't on the panel anymore. They've changed things since. It's not like that anymore. It's not and so it got through, but the client then wanted to change it again, so we redesigned it, etc. So probably we always said we didn't like this design, the way it went in the ladder, but we were happy with the materials, because this is where we introduced the Hebel panel. We talked about Hebel with the clients for probably 6 to 12 months in the design stage, and they really weren't coming at it until then, when we came back to start redesigning. They said, oh, we've seen this product being used around the corner, can you come and have a look? So we went and had a look, and it was Hebel, so that's what we were talking about a year and a half ago. So they were quite happy with that, and that's how we sort of got that through. But since then, Tea Tree Gully Council on their website has examples of what they want as sort of that urban infill around the area, and there's almost this exact type development is what they're supporting this, and they've given examples of it. They've done their own modelling, but it's exactly the same type of thing. They say this is sort of what it's acceptable. So it was just a case of wrong time, I suppose. We're a bit too early for what they were thinking for Tea Tree Gully, even though their council was very forward thinking. They were way ahead of sustainability, and the council house had its own rainwater storage, all that sort of stuff back then when it wasn't really a thing. So yeah, so that's a bit of background information of sort of how it went. So it was a pretty, as I said, long-winded project, but everything that's in this project is sort of something that's slightly out of the ordinary. So it's not an exceptionally designed building in terms of architectural features or anything, but you know, from the Hebel panel at the time, no builders were using Hebel. No one wanted to touch it. We'd done a few projects in Hebel. It was really hard to find builders at the time to actually use the product. Everyone just wanted to do brick veneer, because they knew they could wake up in the morning and not think about what they were doing and do brick veneer. So Hebel they had to think about it. Oh, we've got to think about how we're going to do this job. But now, you know, probably a few years after that, every contract we had, the builders were saying, oh, can we use Hebel for this? Because then they all of a sudden loved it, the ease of application, etc. The box gutters, again, the flatter roofs, you know, trying to fit what the client wanted in this size building. The clients didn't really have an idea of scale, so you'll notice that like the master bedroom is absolutely massive, like way oversized, and the lounge room was quite small. So, and kitchen was quite small. So that was sort of all sort of client driven. We were sort of trying to, and so they did make some changes when it got to site as well, when they realised and saw it as it was set out and started being framed. They were thinking, whoa, this is a bit different to what we thought. So, so that's why there was some changes later. We used a suspended ceiling as well, so it's not just timber ceiling joists with plasterboard stuck to it. It was actually like a rondo system, which is really a bit more commercial. It happens a lot more now in two-storey houses, but it's a bit more like what you're sort of seeing suspended here. So that's another detail that you've got to investigate and have a look for this project. And the other thing the clients really wanted was 2.7 as a minimum floor to ceiling height on both levels. So top and bottom level. And obviously there was some floor joists involved which had a size, you know, they were sort of close to 400. And when you added all that height up, it was much greater than what council said they wanted as a maximum height of building. So we had to start squashing things in. So there was lots of things that were like millimetre tolerances in this build, to the point where the builder was ringing us up and saying, can I go up by another 5 mil for this? I can't fit this in, those sorts of things. So eventually the sizes that we work with were 2.7 downstairs, and I think it ended up being about 2.55 or something upstairs. It was even though it was an odd ceiling height, it was like we just couldn't just give them 2.4 because they weren't going to have it. So they were quite happy to just build higher than council, the council restriction. They were happy to do that. So